Hello, my dear students. I am Mukesh Tilwani, Assistant Professor in MMD Textile and Engineering College, Bhilwara. Today, I am going to discuss about the subject on subject manufacturing processes, and the topic I am going to discuss is sheet metal forming. What is sheet metal forming? In sheet metal forming, we use sheet metal as a raw material to form any shape for using in any type of application. We can punch, we can blank, or we can bend the material, and we can form any type of shape like a cup with the help of sheet metal forming. So, what is sheet metal? Product has lightweight and versatile shape as compared to the forging and casting. In forging and casting, we use the raw material as a bulk material. As compared to the forging and casting, the sheet metal has lightweight and versatile shape. Most commonly used low carbon steel sheet. We use low carbon steel sheet for making the sheet metal forming materials because of the cost, strength, and formability. The formability property of the low carbon steel is higher than other materials. Aluminium and titanium for aircraft and aerospace. Aluminium and titanium are both have the low density. Therefore, we can use the aluminium and titanium as a material in aircraft and aerospace, and we can produce the sheet metal products by using sheet metal forming. Sheet metal has become significant material for automotive bodies and frames, office furnitures, and frame for home appliance. First sheet metal forming operation is punching or blanking. What is punching and what is blanking? Both are the shearing operation in which we use sheet metal and put the sheet metal on the die, and we punch with the help of punching press, so that we get the desired product. In blanking, the piece being punched out become the workpiece, and major burrs or undesirable features should be left on the remaining strip. In the blanking, we can see from the diagram that if we force on the sheet metal which has direct contact with the die, it will punch like this, and the piece being punched out become the workpiece. This punched workpiece will become the this punched part will become the workpiece. If then it is called the blanking operation. In piercing, or we can say the punching, the punch out is the scrape, or remaining strip is the workpiece. In punching operation, if we punch the sheet metal, then what we punch, the hole will be the scrape, and the what material we get like this will be the workpiece of the desired product. Both done on same form of mechanical press. This is a diagram. In this is a punch. We force on that. The force is this force is a hydraulic force. We press the sheet metal, and a sheet metal is direct contact with the this is a die, direct contact with the die. If we punch, it will cut the sheet metal in circular form. Clearance is very important characteristic for punching and blanking, because while doing the punching or blanking, the hole is the sheet metal is direct contact with the die. So we should give the clearance between the punch and die, so that because if the material being punched, we get the less or more hole size. Therefore, we have to give the clearance on that. Die opening must be larger than punch and known as clearance. This die opening is larger than the punch, as we know. In punching, punch is the size of the hole. If we have to punch the hole of 6 mm 6 mm diameter, so it will become this size will become the size of the punch in punching operation. And what will be the size of the die? We have to use the clearance characteristic for finding the die size. In punching operation, punch is the size of the hole and die size is equal to punch size plus 2 into clearance. We have to give the clearance on punch size, so that we get the die size in case of punching operation. In punching operation, punch is the correct size. If we have to in final product we want the 6 mm diameter hole, then in punching operation, punch will be the correct size and the clearance is given on the die. The clearance will be provided on the die in punching operation. For blanking operation, here also the size of the die is more than the punch, but here the die size is the size of the hole. For example, if we have to punch 6 mm diameter hole, so die size will be the 6 mm in blanking operation. If we have to calculate the punch size, as we know the punch size is lower than the die size, so we have to give the clearance on the punch in blanking operation. The punch size will be the die size minus 2 into clearance. In blanking, die is the correct size, as I said, and in blanking, clearance is provided on the punch. Continue. The clearance is determined with the help of following equation. This is the equation for calculating the clearance. Here T is the thickness of the sheet. Thickness. It is the thickness of the sheet. And tau is the shear stress. Tau is shear stress. Shear stress while generated while punching the sheet metal. Total clearance between punch and die size will be twice of this, that is 2C. We have to give the clearance twice of this value to the die or to the punch. If we have to there is no any property given in the question, then we have to use clearance as a percentage. So how can we calculate the clearance if percentage is given? If the allowance for the material is A is equal to 0.075 given, then the clearance will be 0.075 into thickness of the sheet. If the clearance is 1% given in the question, then the clearance will be the C will be the 0.01 into thickness of the sheet. In punch or die, we use the clearance twice of C. Now the punching force or blanking force. What is the punching force and blanking force? We have to give force to the punch so that we get the desired product. In blanking we get the product like this. In punching we get the product like this, and in blanking we get the product which has punched, that is circular shape product in blanking operation. The what force required for the punching operation and blanking operation, which is the L into T into tau. As we know, tau is the shear stress generated and T is the thickness, and L, what is L? L is the sheared length. What length shared with punch shared with the sheet metal, which will be the L in the operation. If this is a knife, we have to shear this sheet with the help of knife. We put the force on that. This contact is this length is contacted with the sheet metal, and so the contact length will be the sheared length in case of punching or blanking operation. This is the sheared length. Now the capacity of press. Capacity of press for punching and blanking operation. How can we calculate the capacity of press? The press capacity will be force into C, where C is a constant which is equal to 1.1 to 1.75 depending upon the profile. Thank you so much, student. For today, this lecture is end. I discussed the punching and blanking operation in today's lecture. In next lecture, I will discuss the deep drawing. Thank you so much.